Okay, so I'm going to go through one of these transformer questions here. Um, this is the actual question here, but we'll go through it and then I'll show you what we can use for these sheets that we got in your additional resources too. So it wants us to determine the standard overcurrent size for a transformer arc welder. The rated primary current is 33 amps, duty cycle 100%, and the temperature termination is 75. Again, in the question, it had a termination of 90 degree at the welder, 75 at the breaker. We go with the lowest. This is a bit of a cheat sheet you guys can use. This is in, and I usually hand these out in class. Obviously, you can't use them for your tests. You can use the code, but what it does is kind of take the code rules and kind of brings it down into a little bit of a condensed version. But I'll be going through each one to show you where it is in the code too. But definitely use these if you want. It's kind of a nice little shortcut. So I can refer back to this, but I'll try to be going to the code because that's what you need the most. So first thing we have to do is look at the overcurrent for a transformer arc. So when it says overcurrent here, it says the first rule is each transformer arc welder shall have an overcurrent protection rated set not more than 200% of the rated primary current of the welder. Okay, so that's the first thing, is the primary current. Unless the overcurrent device protecting the insulated supply conductors meets the requirement. So now we're going to read part two. So that's part one. Part two is each ungrounded conductor supplying a transformer arc shall have an overcurrent protection rated or set at not more than 200% of the allowable ampacity of the conductor. Okay, and then it says specified in 1, 2, 3, or 4, except the next higher rating shall be permitted to be used where again, this is the conductor one we're talking about, and we'll go through some examples here. The nearest standard rating of the overcurrent device is less than the rating or setting otherwise required by the rule, so from sub rule 1. So we are allowed to go up as long as we don't exceed that primary ampacity calculation, or it causes frequent opening, so tripping nuisance, if you will. So in this question, what we have to do is we want to find the overcurrent size. The first calculation, so from that sub rule 1, and we see that here too, overcurrent rating. First thing we're going to do is go the rated primary current times 200%. So we take the rated primary current in this case, that 33 amps times 2, and we get our 66 amps. Again, this is from the primary. Now the other one is the conductor that we need to compare. And it's the conductor ampacity times 2, and that'll give us an answer. So we need to find out what conductor we're going to use. So to get the conductor size, we take our primary current and then we times it by whatever duty cycle we have. Now in this one, I'll show you where they're on this sheet too. These are all the duty cycles and the percentages. So at 100%, we're just going to times it by 1. So it's not going to change anything in this question. But if the duty cycles were different, obviously we have a different multiplier, a different derating based on that. And those, just so that we know, are right here in the code as well too. So here's all the derating based on the percentage. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9%. 1, 2, 3, 4, 5, 6, 7, 8, 9 deratings associated. So 100 is 1. If we wanted to see what it was at 60, we've got 1, 2, 3, 4, 5. So 60 is the fifth one. 1, 2, 3, 4, 5. So 60 would be 0.78. Yeah, that's how I do it. You can use a cheat sheet if you want to get used to it first, but ultimately you got to be able to do it out of the code. So in this case, we're timesing this by 1 because that's our duty cycle at the 100%. So we get 33 amps. That's what we're going to put down here so that we can find our conductor now. So at 33 amps, we're going to go to table 2. And in this question, again, the temperature termination is 75 degrees. So I go to table 2, and it's going to tell me I can use a number 10, which is good for 35 amps. Okay, so now the conductor ampacity is what comes down here, and we get 70 amps. So this is where the decision happens. We can't ever exceed the primary current. Okay, so when we get down to this decision of which one of these values we're going to use, you take the lowest. So 66 amps is obviously the lowest, so that's the one we're going to use. But we can't ever exceed that primary current calculation. So then when we go to table 13, we go down and we pick a 60 amp overcurrent. So that is the answer for this question. So every question, when you get down to choosing an overcurrent device, you're going to get down to the primary current times 2 and the conductor ampacity times 2 and take the lowest. Now again, we can never exceed this. So if it's the primary current that you've chosen, you have to go down on table 13. If it's the conductor ampacity, you are able to go up, and it says that in the code, and I can show you in a sec here, but we can still not exceed this number, the 66 amps. So if by going up we would exceed that, then if we use this value, we go down on table 13 as well. Okay, and that's what it says in this rule right here, is basically saying we can go up, we go to the nearest standard rating, we shall be permitted to use the next higher rating. Again, as long as we're not exceeding, the device is set less than subrule 1, which would be the primary current. Okay, so we can go up, but we still have to maintain that ceiling, if we will, from our primary current calculation. Okay, so that's one question, a style of question you'll get. You can do another one here just for a single welder, and then we'll get into a group. So let's make another one here. Again, an overcurrent we want to find. It's a transformer arc. I'll do transformer arc first. I'll do another video for resistance welders. So let's say we got a duty cycle of 60%, and then we got a primary current. We'll use 38 amps, and we'll say 75-degree termination temperature. So now again, first thing we want to do is say we got our two rules. One is the primary current, 2 is the conductor ampacity. Okay, so those are the two things we're going to compare. So my primary current, again, is this 38 amps. So I take that times 2, that's at 200%, and I get 76 amps. Now we need to find the conductor size for this. So a bit different here. Now we got a duty cycle of 60%. So if we go back to our list here, I'm looking for 60%. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's 0.78. Okay, and again, you can see that on this sheet a little clearer because we've kind of pointed it out for you guys, but we can see that at 60% it's 0.78. Okay, but that's right out of the code. So, and we take to get our conductor size, ampacity, we want to take our 38 amps times 0.78, and we get 29.64 amps. Now we go to table 2, and under the 75-degree, and we find out we can use a number 10. It's good for 35 amps. So this is the ampacity that we're going to bring down to here. Okay, so we got 35, that's a 5, sorry, times 2 equals 70 amps. So now we get to this point where again we choose the smaller. So the primary current is higher in this one, so we're actually able to choose the conductor ampacity. That's one we're going to go with. So now when we go to table 13, we're going to look and see, is there a 70 amp overcurrent? And there is, for sure. So we pick 70 amps. Again, we haven't exceeded this 76, so we're okay. If you made a mistake and chose this and went down to 70, you'd get the right answer, unfortunately, but you'd be doing it incorrectly because we're choosing the lowest here. So that's why we're using this 70 amp, is based on this number here. If this number didn't happen to be in table 13, and we could go up from table 13, again, as long as we didn't exceed the 76. Okay, so just watch out for that. Okay, so this is the answer for this question. Okay, it's always going to get down to the two calculations we're going to decide. That's what this says here too on this little cheat sheet here. We're going to do the rated primary conductor, the rated primary current by 200, the conductor ampacity by 200, and then it's saying if one is greater than or equal to 2, then choose 2. If one is less than 2, choose 1. Basically choose the lowest. That's what I've written here. Take the lowest of the two. And then go to table 13, and it says you can use any value from table 13, but do not exceed value 1. Okay, so if we choose the conductor ampacity, we can go up, but we cannot exceed that rated primary current calculation. Okay, so let's look at a bank here, and we'll kind of see a similar scenario. I'll show you what's written in your guys' question here. So this is what's being stated in a question for a bank. This is right out of your blackboard. So it's giving us all the primary currents of the welders. It's giving us all the duty cycles. And then it actually is also giving us all the percentages already. So it's gone through and said all that stuff we don't have to do. We've already had it listed in the question. So then we can get our calculation, our ampacity based on those duty cycles. So what happens when we're going to just size the feeder? Okay, so this would just be the feeder. If we look at this rule here, so feeder conductor, sorry, not the feeder overcurrent, we're doing the feeder conductor. So that's this rule here. So under supply conductors, it says the insulated supply conductors for a group of transformers and arc welders shall have an ampacity not less than the sum of the currents determined for each welder in the group accordance with sub rule 1. So those calculated values. And we're going to put 100% of the two largest calculated currents towards the main feeder conductor. We're going to put 85% of the third largest one, 70 of the fourth, and then 65 of the rest. So in this question, we had 4 welders. So what we're going to do is take 100% of the two largest calculated. So we look over here at our calculated values. 36 is our largest, and 29.45 would be our next. So I'm going to put those in at 100%. Then the next largest one at 85%. So that's this guy here, this 26.25. It's going in at 85%. And then the next largest one for us, the last one, at 70%. So we add all those up and we get 105.82 amps. Then we go to table 2 and size our conductor. Again, based on 75 degrees, we take this number, go to table 2, and we see we can use a number 2 that's good for 115 amps. So it's a bit more involved of a question because we have this step here where we have to follow that rule for the first two calculated values. Again, calculated values, not these, not primary rated values, these calculated values, because that's what it's actually going to draw based on the duty cycle. Then we take the two largest. Again, we're kind of being able to derate our conductor, assuming that they're not all going to be on all the time, drawing current all the time together. So we take the two largest values to make sure we're covering those. Then we start derating based on the lower ampacity draws on the calculations. Okay, so that's to do a primary conductor. Now to do a primary overcurrent, we have a bit of a different scenario. So this is how I set them up. This again, this top part right here is right out of blackboard. So they give you 3 welders. They give you the primary. So this was the primary current. This was the duty cycle. And then here's our calculations based on those duty cycles. And then here's the conductor size. Okay, so done all this for you. It's already set up in the question. So, but this is literally what I did in the previous examples, where we took to find the conductor size. So we're just doing that for each one, but we've done it for you guys. Because what's more important in this question is I want to know what the total overcurrent size is. So we look at these rules. Again, now we're looking for the overcurrent value. So we go back over to the overcurrent section, it's saying the maximum rating or setting of an overcurrent device protecting a feeder supplying a group of transformer arc welders shall not exceed, so we're going to go down when we get this value, a value calculated by determining the maximum rating or setting of an overcurrent device permitted by subrules 1 and 2. Okay, so that's us finding out each individual welder's overcurrent, the highest value of overcurrent protection. So that's a value from table 13. Then adding to this, the value sum of the ampacities is calculated in 42006 for the other welders in the group. So if we go back to 42006 for all these welders, we're going to be using these percentages for the rest of them, okay? But we're going to take the largest overcurrent that we've calculated. Then we're going to take the next one, because we've already taken one, we're using the overcurrent of the largest. So then we'll take the calculated value of the next largest, then the next one at 85. Okay, so I'll show you that here. I just want to show you, that's resistance welders. I want to show you too, this is all on this little cheat sheet here too. So if we want to do the feeder conductor, this is the one I just did, 100% of the two largest. Again, these are calculated. Okay, now we're doing the feeder overcurrent, and that's a little shortcut right here, but I'll show you how we do this step by step. So again, this is what they gave us in the question, these first three lines. Now we have to figure out all the overcurrents, because we need to see which one is the largest, because that's how we're going to do this calculation. So what I do is I set up my welders, and then I set up primary current calculation and conductor ampacity, because we're going to basically size an overcurrent just like we were doing in the previous example. So the primary is 41. I take that times 2 and I get 82. Then my conductor for welder 1 is a number 12 at 25 amps. So I take the 25 times 2. Now I'm deciding between the 82 and the 50, which is smaller. Well, the conductor ampacity is. So I go to table 13, and there happens to be a 50 amp breaker, so that's what I'm going to use for welder 1. So this is the overcurrent for welder 1. Welder 2, same rule, just use its primary current times 2, get 58 amps. And I use the conductor ampacity for the second calculation, so 35 times 2. Again, that's this 35, that's why I'm using it, the conductor. And we get 70 amps. Then again, we choose the lowest, but in this case, we hit 58. We can't exceed 58 because that's a primary current calculation, so we go down to a 50 amp from table 13. Okay, again, always choosing the lowest. Then this one here, welder 3, we go to the primary is 38 amps. Get its wire size is 50 amp, it's a number 8 rated for 50 amps. So I take the primary current times 2, get that calculation, take the wire ampacity times 2, get that one, then choose the lower of the two. Again, we have to go down at table 13 because this is a primary current and we cannot exceed it. So this is the overcurrent for welder 3. So what the rule is saying is we take the largest overcurrent out of all these welders. So out of the 250s and the 70, we take the largest overcurrent. So that's the first number I got here that I'm going to add in, is the 70, the overcurrent. Then it says take the next largest at 100% of the calculated value. So we are using that welder number 3, so we've already used this guy for our calculation. Now we need to know what's the next largest calculated value. So that's this value right there. So that's what I'm going to put at 100%. So that's going in right here, 25.81. Then, so that guy's taken care of. Now, our last one, in this case, we go to this guy here, welder 1, and we're going to take 85% of its calculated value. So its calculated value is right there, that 22.55. So we're going to take 85% of that. Then we add them all up, and we get 114.98. And again, that rule said we can't go above that, or that's a maximum calculated value. So then we go down to table 13, and we'd use 110 amp overcurrent from table 13. Okay, so those are the questions you're going to get for welders for transformer arc. I'll work on some resistance ones as well next. They're very similar, just some percentages that have changed. Okay, so hopefully that helps get you through those style of questions. Use that cheat sheet if you can. If you want to just use the code, go through it. The code's just not super easy to read the first time. So it's nice to have that little bit of a kind of a condensed version of the code rules. But again, you cannot use that for your tests, so you got to know how to do this straight up. So yeah, if you have any questions, let me know.